So here we're working through the exponential graph and logarithmic graph questions from exercise 7K in the book, particularly looking at question 4, 5 and 6. These questions are mostly focused on sketching graphs and finding inverses of graphs, so they're all actually quite similar questions. We'll work through each one, but once you've seen the first one, you might then be able to figure out how to go about the other two without having to watch this. Let's look at the first one. So here we have to find the composite function, g f of x, of these two functions here. Remember, if it's g f, that means the f happens first, then the g happens afterwards, and then give your answer in the form ax plus b. So we'll have a look at that now. Well, if we're doing the function f first, that means that we've done this function here, ln x plus 2. That's already happened. What then happens is this result goes into the g function. So I like to write this like this, because I'm going to put this whole thing here into g. Now g was, just quickly look at this again, g was 2 e to the x. So this x here is going to be replaced with what is now going into the g function, which is this whole thing here. So you get this kind of complicated looking thing here, but it's 2e, that's just the original g function. The x in the g function is now replaced with what is the input now, which is ln x plus 2. Now that is the answer, that's the final answer, except that it wants it written in a different form. You have to realize here is that ln x plus 2, that is saying what power of e would give you this result. Remember, in logs, and this is a natural log here, we've got this kind of setup here. So let's take an example where we've got maybe just a number 5 there, and we don't know what the answer there is going to be. But this here is saying what power of e would give you the result of 5. So it's saying if you knew this, you'd go e to the power of this question mark, and that would be 5. But we don't write log e, we write ln. That means log base e. So if you think about that relationship here, we're saying what power of e would give you this result of x plus 2. Well, whatever it is, we are actually raising e to that power. So the result of all of this, ignore the 2 for a second, the result of all of this is going to be x plus 2, because you're raising e to the power of e that you need to get x plus 2. Hopefully that makes sense, the way I phrased that. So that then is going to simplify to 2 multiplied by x plus 2, which you can expand to 2x plus 4, which is the function you're looking for. So that is the composite function g f of x. Okay, so that is the composite function, but the next part of the question is asking you to determine for the equation f of x, so just go back to what that is. That's this logarithmic function here, ln x plus 2. We need to find the equation, determine the equation of any possible asymptotes, exact coordinates of intersections, and then later on sketch the graph. I think these are really the same question. So whenever you're sketching a graph, you need to find, as the question implies, intersection points, so where it's crossing the x-axis and the y-axis, and any asymptotes that the graph might have. So let's start with the intersection points. Well, where it crosses the y-axis, the x is going to be 0. So looking at the actual function itself, if you make the x 0 here, that's going to become the natural log of 2, because that x is going to disappear. That's a pretty easy one, actually. When x is 0, y is just going to be ln 2. You could go on the calculator and work out what that actually is. It's going to be a number. It's just whatever power of e gives you 2. So it's going to be some horrible decimal. I'd keep it as it is. Let's just write the coordinate as 0 ln 2. So we'll plot that on the graph later. The x-intercept is when the y equals 0. So I'm going to do the same thing. I'm going to write y equals 0 here. go back to the function itself. Well, how are you going to get the answer of 0 out of this? Well, do you remember what the function is actually doing in this case? It's saying what power of e would give you 0. Just to make that, again, really explicit, let's go back up here. The general kind of power relationship with these logarithms is if we take, let's say, e to the power of, let's say, the unknown x, and it equals 5. Remember, this is the power. Let's call that the result. And this e in this case is the base. Can get base 10 or base 7 or anything like that as well. Base 10 and base e are the most common ones. When we write it as a log, we're saying that the base is e. We're saying the result is in here. That's the 5. And the power is now the answer to this expression. So in this case, we don't know what it is. It's going to be x. And that's the power. So going back to this function here, how would we get the result of this to be 0 so we can find the intercept? Well, it's saying if the power is 0, what would the result have to be? Well, anything to the power of 0 is 1. So if you get this thing inside here to be 1, that means the power must have been 0, therefore the output is 0. So how would this be 1? Well, it would be 1 if x was minus 1. So that is going to be our intercept. Now remember, the actual coordinate is going to be minus 1 first and 0 second, because it's the x is the first one. So these are the two intercepts here. The asymptote is kind of works out in a similar way. Remember, asymptote is the value that the graph will never quite reach, either on the x or the y-axis. So to investigate that, I'll just look at the function again, and I'll think, well, what about x? Can we make x as big as we want? Could that x be 10? Yeah, sure. There's no reason why it can't be, because remember, it's just the result of a power of e. Could it be 1,000,000? Yeah, you just have to keep increasing the power of e. In fact, it can be as big as you want, but it couldn't be negative. Remember, the lowest you can get from any kind of power expression is 0. Even if the power is like negative 1,000,000, that still means it's going to be a fractional answer, not a negative. Just to make that a bit more clear, maybe just in this little box up here, if we have e to the power of minus 5, right, well, that doesn't mean a negative number. It's going to be 1 over e to the 5. So the result of a power is never going to be negative. That means that this bit inside the natural log can't be negative. So the lowest x can be, well, it can't even be this, but it can approach minus 2. So you can say that the graph will have an asymptote at x equals minus 2. So it's never going to quite reach that. In terms of the y, can the y be any values at all? Well, remember, the y is the power of e. And yeah, it can be any power, can't it? I mean, you can have e to the power of 1,000,000 or minus 1,000,000. That's not a problem. So the output for that is going to be anything. So actually, that's the only asymptote we've got here. Question C is asking to just use this to sketch the graph. So a sketch does not have to be particularly accurate or artistic. Probably use a ruler. I'm not going to bother with that. And you don't have to either on this particular question. Maybe in the exam would be a good idea. But let's just put on the information we've got. Okay, 0 ln 2. So as the x0, it's going to be about there. What you should do, though, is label the points very clearly. So that's that. And then minus 1, 0. So that's going to be along here. Minus 1, 0. The asymptote of x equals minus 2. Well, minus 2 on the x is there. So asymptotes are normally drawn with a kind of dotted line like that. So it's not going to go past there. You need to also know the shape of the graph. Now, one of the previous tasks asked you to investigate the shape of log graphs. Hopefully you've seen that it's kind of a slow, increasing, sloping curve. If you're not sure about that, go on Desmos, type this in, you'll see that the graphs will have a very similar shape. Doesn't really matter what number's in here. It could be ln x, it could be ln 2x, it could be ln 10x, it could be 7 ln x squared. We're all going to have a very similar kind of shape. So once you know that, or you can recognize that, or go on your GDC and type it in as well, of course, you'll be able to roughly sketch this kind of shape. And that's the graph sketched. We actually have another part of the question, which is 4D up here, which is asking you to determine the inverse function of f of x and sketch it on the same set of coordinate axes. So let's get the inverse first. Now the f of x is this ln x plus 2. Now to do an inverse, we write that using this y placeholder, and that's the original function. Inverting it means replacing the x and the y, so making this the subject and this the input variable. Well, how do we inverse this? Well, the opposite of doing a natural log is having the power of e. Another way of thinking about this is that if you're doing a natural log, the answer to this is the power of e that you would need to get this result. So you can immediately rewrite this as saying, well, it would be e to the power of y, and that would give you x plus 2. That's what that means. So these two are exactly the same thing, just rewritten in different ways. There's the kind of the result. This is the power of e that you need. And so I've written it as a power of e with that as the result. Let's just subtract the 2. And that is our inverse function. But on inverse functions, you rewrite it with the f minus 1 x, and then you use the x in this position, because the y isn't really a thing, it's just a placeholder we use to do the algebra. So the actual function is this, but it is written in the same sort of way as the last one. So we've just got to sketch that on the graph now. Well, if we go through the same process as before, we need to know the intercepts, we need to know the asymptotes, and then we can put it on the graph. So let's do the intercepts first. Well, when x is 0, then what's going to happen here? So if you make that a 0, that's going to be power of 0. Anything power of 0 is 1. So that's going to become 1 minus 2. So you've got minus 1. What about when the y is 0? Well, in this case, it's this f minus 1 of x equals 0. The output is 0. How are you going to make this equal to 0? Well, that means that would have to be 2, wouldn't it? Because it would be 2 take away 2 would be 0. So, well, here's where you can use logs very effectively. Like, you could go on the GDC and you could work out what power of e is equal to 2. But the whole point of logs is that you can write that like this. What power of e, that's natural log, gives you 2, well, is this. That's what natural log of 2 means. I'll just maybe highlight this here. So it's saying that's that. Now you can go on the GDC and you can type this in. In fact, you can type this in on the GDC, on the solver, and it will give you the decimal answer. I highly recommend keeping it this way though, because you've then got an exact value that you might be able to work with later and not round it. So let's keep it like this. Asymptotes as well might be a factor in this function. So again, think about the x first. How big can this x get? Is there any limitation? Not really. You could have power of 1,000,000 there. That'd be fine. Just be a really big number. Can you have negative x's? Yeah, you can have negative powers. Remember, this is never going to be a negative value in itself, but the power can be negative. So there's no restriction on x there at all. The y, on the other hand, can that get as big as you want? Yeah, because if you make this x really large, that whole thing's just going to get really big. So the y is going to go off to a really large value eventually. But is there going to be a lower limit? Well, if you make the x really, really, really small, let's say negative 1,000,000, remember that's never going to get below 0. It's going to become a really small fraction. So you can get pretty close to 0, but you're still going to be left with minus 2. So y equals minus 2 is an asymptote on this graph. All right, we've got enough to sketch it. I'm actually going to sketch it separately here first, and I'll put it on the original graph as the question asks. So we've got x0, y minus 1. I didn't write the coordinates down, actually. It's probably a good idea. So that's 0, minus 1. Let's put that on there. So 0, minus 1. So that's about there. This one here, ln 2, 0. So that's going to be about there. and got y equals minus 2 as this asymptote. You see that one? That's the y equals minus 2. It's an exponential graph. Now, if you guys don't know what an exponential graph looks like now in this current climate, if you're watching the news at all, you'll see an exponential graph all over the place. It's a shape that comes along like this and then gets really, really big, which is a bad thing in some cases. So we're going to draw that. Again, the sketch doesn't have to be perfect, but it's that kind of shape. If we put it onto the original graph, you might have already noticed that there's a nice kind of symmetry here. Maybe not particularly surprising. In fact, noticing the symmetry can be a shortcut to sketching these graphs of inverse functions. So it actually looks exactly the same, just reflected in this y equals x line. And that is exactly how inverse functions work. You may remember us going through an example of this. If you just rotate the x and the y-axis, if the x-axis becomes the y-axis and the y-axis becomes the x-axis, then you'll see you've got this. It's quite hard to do this with just paper, but use your imagination. X becomes the y and the y becomes the x, so they're like flipping on top of each other. It is like a mirror has been placed down the middle there. And that is exactly what the algebra does, isn't it? It replaces the x and the y in their respective positions. So on the graph, it would make sense that you're mirroring that position. So that's your final answer. Now, I will go through the other questions, but I think on this video, I'll leave it here for now, and then I'll do the other questions in written form later on. But they are very, very similar. So here you've got to just consider the function f of x equals 10 to the power of x. It's a very similar thing. You're just now going to use regular log instead of natural log. Once you've got the inverse, sketching the graph's the same. Find the intercept points, think about where the asymptotes could be, and then sketch it. This is exactly the same as well. Don't be afraid to use a GDC to sketch the graph. You've always got that in the exams. You can always look at it and go, okay, it should be a bit like this. Am I getting the right thing from my algebra? And while you're working at home, of course, you can use things like Desmos as well to see the graph. So have a go at those. I will put the written answers to the other ones up later on, but hopefully going through that question like this has been useful.